next up, the two sections are by Daniel. He will talk about first encryption, which is the low-level encryption of all the content in Swarm, and then about access control, which is making sure that only the right people read the right content. So, Donnie.
Hello, everyone. I'm going to talk about how you store confidential information in Swarm and how you limit the users which can access it. So confidential information in Swarm is encrypted using counter mode encryption, which you can find the basic security properties in Wikipedia. However, we use our own version of it, which is a slight modification. So instead of the block cipher, which really is just a one-way function with a reverse gear, which CTR encryption doesn't use anyway, we use SHA-3 twice, which is the same hash function that is used throughout Ethereum. And we use it twice because with accessing that little piece of data that is denoted by that pink arrow, what you can do is you can partially reveal plain text inside an encrypted volume or an encrypted file in such a way that a smart contract can actually verify it, which means that you can make various commitments on the blockchain in smart contracts regarding the plain text of certain encrypted content. And if there's a dispute, you can reveal a piece of data that does not reveal your access keys or anything else, just reveals a little part of your encrypted content, whatever it is. This is vulnerable to what cryptographers call existential forgery, but if there's any integrity protection in place, then this is not actually a security problem. So this is how we encrypt. And in practice, for application developers, this means the following, that compared to unencrypted Swarm, the references are no longer plainly root hashes, but hashes of the ciphertext plus the decryption key. So they have grown from 32 to 64 bytes, but otherwise nothing else has changed. The API is exactly the same, and so is the data model, meaning that if you have already written distributed applications for Swarm or looked at the example ones that we have in our public repository, they would work without modification on the encrypted Swarm. So this is a native encryption API on top of Swarm, and every Swarm node supports it. And the only cryptographic assumption that we make is the security, the collision resistance of the SHA-3 hash function. Now, so we have not actually increased the attack surface beyond what Ethereum already assumes. And if SHA-3 is broken, then we will have much bigger problems. And finally, we have designed our encryption so that it's as smart contract friendly as possible. So now I'm going to move on to access control in Swarm, which basically boils down to how do you change the sets of users that have access to certain content. So it's important to emphasize that in a permissionless, trustless, and distributed system, you can not really act as a gatekeeper, or you cannot really delegate nodes to act as gatekeepers. Instead, read access corresponds to the ability to decrypt, and write access corresponds to the ability to register. So registration can happen on Swarm feeds or directly in the blockchain, for example, in an ENS contract, and that's about what you need to know about it. But read access, which is the ability to decrypt, is a bit more interesting, so I'm going to talk more about that. So there are three strategies in which you can identify authorized users to access content. The simplest and most intuitive, perhaps, is a passphrase. So you can make content accessible to users that know a particular passphrase. So in this case, both the publisher and the consumer needs to know that passphrase. which of course has the disadvantage if the same user needs to access content by 2 different publishers, then those 2 publishers can also access each other's content. So in order to mitigate that, we have a more sophisticated access control mechanism, which is public keys, public-private key pairs. And at this point, I would like to draw your attention as developers that these public keys are not Ethereum addresses. These are actually points on the elliptic curve of which Ethereum addresses are the hashes. So you need those in order to as a publisher, to identify your consumers, and as a consumer, you need to have the corresponding private key. And the most sophisticated and most finely grained access control mechanism that we have implemented in Swarm is access control trie, or ACT for short. This is basically an efficient organization of access control lists. And in these lists, you can have users of both kind, so both passphrases and public keys, in such a way that there's no information disclosed beyond an upper bound on the size of the ACL. So anybody who can access the access control trie can have an upper bound on how many items are there, but beyond that, they have no clue how many users can actually access it and who those are, even if you're one of them. You can only check whether or not you're one of them, but you cannot peek into other people's permissions. Very importantly, since access means ability to decrypt, you cannot really withdraw access. What happens if you exclude somebody from the access control list is that they're not going to be able to read future updates. They're still going to be able to read what they have read before, especially if they have cached all the keys that they have access to. But if the resource is updated, then they won't have access to the update anymore, only to the old versions. But it's also a very neat property that if you change the ACT, you don't need to re-encrypt the content because we're using multi-stage encryption, and you basically only need to re-encrypt the reference that I talked about earlier, the 64-byte reference. Also, granting access, extending the access control trie is a logarithmic operation. So if you want to add another party to your access, then the number of encryptions that you need to do is a logarithm of the number of grantees. Revoking is a little bit more expensive. It's linear in the number of grantees, precisely because you want to re-encrypt a new encrypted reference so that those whom you have excluded will no longer have access to the updates. And finally, I would like to draw your attention that the granularity of this is very similar to that in a Unix file system, so you can have per directory permissions, per file permissions, and so on. So you don't need to have an entire swarm volume under the same access control. So before I finish, I would like to give you one warning, and this is the last thing I'm going to say, and hopefully this last one you remember, that if you're dealing with access-controlled content, please don't use public gateways. Run your own Swarm node. Because if you're using a public gateway, that gateway will have access to the same access-controlled content, and you might not want to have that. So thank you so much.